All right, let's talk about Python's big secret. There's something at the very core of the language that feels a bit like a magic trick. It's the thing that makes so many developers just, well, fall in love with it. So what is it?
Have you ever felt this? You sit down to write some Python, especially if you're coming from another language, and you just fly. It feels so direct, so quick. The question is, why? What's going on under the hood that makes it feel that way? Well, here's the twist. The secret isn't some fancy, complicated feature you need to learn. It's actually the complete opposite. It's all about what Python doesn't make you do. It's about what it leaves out.
And that brings us right here to Python's surprising simplicity. This is the thing that often catches programmers off guard, especially if they're used to more rigid languages.
This is it. This is the big one. In so many other languages, you have to tell the computer ahead of time, hey, this variable is going to hold a number, or this one's for text. You have to declare it with int, string, whatever. Python just says, nah, don't worry about it.
You just do it. You write x equals 10, and Python just gets it. It figures it out all on its own. And that tiny change has these massive ripple effects on how fast you can turn an idea in your head into working code.
So this magic we're talking about, it has an official name. It's called dynamic typing. And honestly, it's probably one of the most important things to understand about how Python works.
Okay, so what does that actually mean, checked during runtime? It just means Python waits to figure out what type of data something is until the very moment that line of code is actually running. It doesn't decide beforehand. The type is flexible. It can change while the program is actually executing.
Now, this is maybe the most important takeaway of this whole explainer, so let this one sink in. In Python, the number 10 has a type. It's an integer. The word hello has a type. It's a string. But the variable, x, it's just a label. It's a name tag that you can stick on any value you want. The variable itself has no permanent type.
Let's just walk through it. First, you stick the label x on the value 10. Great! Python sees that 10 is an integer. A few lines later, you decide to peel that x label off of 10 and stick it onto hello instead. And Python, it doesn't complain, it doesn't throw an error, it just goes, okay, cool, x points to a string now. It just adapts. Now, to really appreciate just how flexible this is, it helps to see the other side of the coin. Let's take a quick look at how a lot of other languages handle this with an approach that's called static typing. In those languages, you have to make a promise right at the beginning. You have to formally say, okay, computer, this variable I'm creating, x, is going to be an integer, and it will only ever be an integer. You're locking it in from the start.
And wow, when you put them side by side, the difference is just so clear, isn't it? On the left, you've got that extra ceremony. You have to declare the type, int, before you can do anything. And on the right, you've got Python. Direct, clean, simple. It's just less typing, less to read, less to think about.
But hold on, this isn't a simple case of one way being better than the other. It's a classic engineering trade-off. We're gaining all this incredible flexibility, but what are we giving up to get it?
So the upside is massive, right? We can prototype ideas way faster because we're not bogged down writing all this extra boilerplate code. You get to spend your brain power on the actual problem you're trying to solve, not just on satisfying the language's rules about types. It just gets out of your way.
But here's the catch. Because Python waits until the last second to check types, some errors can hide in your code until it's actually running. You might have a bug where you accidentally try to add a number to a word, and you won't find out about it until that exact line of code runs, which could be way later, maybe even when a user is using your app.
So does that mean we're just stuck? Do we have to choose between moving fast and writing safe, reliable code? Well, for a long time, that was kind of the deal. But not anymore. Modern Python has come up with a really elegant solution.
And here they are, optional type hints. You can see the syntax is super clean. You can choose to add a little note, a hint, about what type you expect a variable to be. Now, this doesn't change how Python runs the code. It's still dynamic underneath. But it gives tools, like your editor, a chance to spot mistakes for you, giving you that safety net back without sacrificing any of the flexibility. It's the best of both worlds.
Okay, let's zoom out for a second. Because this whole discussion about dynamic typing, it's not just a random technical feature. It actually reveals the deep underlying philosophy of the whole Python language.
This is a line from the Zen of Python, which is basically the language's guiding principles. And dynamic typing is the perfect example of this idea in action. It avoids upfront complexity to make the programmer's life simple.
And this isn't just an abstract idea. You can see the real-world results everywhere. I mean, look at where Python dominates. Startups that need to build things fast. Data science, where you're constantly experimenting. Automation, where you just want to get a script working quickly. All these fields thrive on speed and flexibility, which dynamic typing enables.
So when you boil it all down, Python's big secret is that it's a language designed for humans first. It consistently chooses to make the developer's job easier, more intuitive, and more productive, even if that means making the computer do a little extra work behind the scenes.
And that leaves us with one final thing to think about. In a world filled with incredibly complex technology, maybe the single most powerful feature any tool can have isn't technical at all. Maybe it's a deep philosophical commitment to putting people first. What do you think?